Welcome to the session number 34 from the playlist of JEE Mains Physics Part 2. The topic is torque versus equilibrium, and with reference to this topic I have taken one question which is written on this board. This question was asked in the JEE Mains examination in 2015, and the question here is: a rectangular loop of side 10 cm and 5 cm carries a current of 5 ampere. It is placed in a uniform magnetic field along the positive z direction. So the direction of the magnetic field is along this positive z direction, that is like this. So this is the direction of the magnetic field, and here we have to find the orientation which depicts the stable and the unstable equilibrium. So for the stable equilibrium, the torque acting on this rectangular loop carrying a current of 5 ampere should be equal to 0, and the angle between the dipole moment and the direction of the magnetic field should also be equal to 0. That is, theta is equal to 0, where theta is the angle between the direction of the magnetic moment and the direction of the magnetic field, and torque is basically equal to mv sine theta. So torque will be equal to 0 when theta is either equal to 0 or it is equal to 180 degree. When theta is equal to 0 degree, then it is the condition of stable equilibrium, and when theta is equal to 180 degree, then it is the condition of unstable equilibrium, and in both the cases the torque will be equal to 0. So here we have to first of all find that figure from these four figures in which the angle between the magnetic moment and the direction of the magnetic field is 0, and we have to also find the figure in which the angle between the direction of the magnetic field and the magnetic moment is 180 degree. Now there is, as all of you must be knowing, that the magnetic moment, the direction of the magnetic moment is always perpendicular to the plane of the loop, and it is directed outward if the direction of the current is anti-clockwise, and it is directed inward when the direction of the current is clockwise. So from these four figures, from here you can see, and from the figure number 2 here, that the direction of this current is anti-clockwise. So in this case, the direction of the magnetic moment will be like this, that is, it will be perpendicular to the plane of the loop like this, and it will be directed outward. So this is the direction of the magnetic moment. This is the direction of the magnetic moment, which I am here depicting it with capital M. So this is the direction of the magnetic moment when the current is flowing in this anti-clockwise direction, and it is lying in the xy plane. So when it is lying in the xy plane, then the direction of the magnetic field will be along the positive z-axis, and it will be directed outward. Now, if you see here from these four figures, in the figure number 4, the direction of the current is clockwise. So here in this case, the direction of the magnetic moment will be directed downwards, that is along the negative z-axis like this, and here the direction of the magnetic field is along the positive this z-axis. So in this case, in the figure number 2, the angle between the direction of the magnetic field and the direction of the magnetic moment is 0. So in this case, the torque will be equal to 0, and since here the angle between the direction of the magnetic field and the magnetic moment is 0, so this figure depicts the condition of stable equilibrium, that is figure number 2. Now in the case here, in the figure number 4, here the direction of the magnetic moment is along the negative z-axis, and the direction of the magnetic field is along the positive z-axis. So here theta is equal to 180 degrees, and torque will be equal to 0, because sine 180 degree is equal to 0. So torque is equal to 0, theta is equal to 180 degrees. So this figure depicts the condition of unstable equilibrium. So our correct answer from these four options will be C, because this figure 2 depicts the condition of stable equilibrium and 4 depicts the condition of unstable equilibrium. So thank you very much for joining this session. In the next session, I will be coming up with a different topic, but the this chapter will remain the same. That is the moving charges and magnetism. So till then, have a nice day. Bye.